this assessment, we're asked to show the mechanism of the forward direction of a reaction shown in one of the figures. In this case, I've drawn the reaction here. We're going to look at it in this direction where it is the hydration reaction of an alkene. The reaction is going to start when sulfuric acid and water react with each other to give H3O+. That's going to be the acid that starts the reaction. The reaction is going to begin by the pi electrons grabbing the proton from H3O+. We're going to put the carbon, or the proton, on the carbon that leaves behind the most stable tertiary carbocation. That makes sense because we're eventually going to have the hydroxyl group attached to that carbon, and now we have a way for that to happen. That's going to happen by water donating a pair of electrons from the oxygen to the empty p orbital of the carbocation. When that happens, water brings along its proton so that at this point we have an acidic proton in the molecule. With water as the solvent, there's lots of it around, so another molecule of water can come in and remove that proton to give us the alcohol as our product. The other thing that forms in this last step is H3O+. This reminds us that this is a catalyst in the reaction. The reaction started with H3O+. It finished with H3O+. It was faster because H3O+ was there. So this is an acid-catalyzed reaction.